All right, y'all. I'm going to demonstrate this live on our Zoom meeting a little bit later, but I figured it would be a good idea to kind of walk you through the basics of the endocrine lab I have you doing this week. There's a couple different aspects of the endocrine system that we're gonna explore. One we've talked about quite a bit with the thyroid. The other is something that we haven't talked about nearly as much with the ability of the pancreas to control blood glucose levels. I'm broadcasting to you live from my dining room, ready to kind of walk you through this lab. So on the screen, you see the first experiment in the endocrine system physiology lab that deals with metabolism and thyroid hormone. And the whole premise of this is to compare a normal rat number one down here, to a rat that has had its thyroid removed, that's the TX we see here, and a rat that has had its pituitary removed or irradiated, which is the hypo-X here. So the way we're going to do this is we're going to measure the amount of oxygen that each rat consumes. As we know, in order to break down food, you need oxygen. So the amount of oxygen that the rats are consuming during a given period of time is going to be what we use to figure out how fast its metabolism is going, or at least to compare. So there are a few little bits of math that we need to do to determine the basal metabolic rate, or BMR, for each of these three rats. So I'm going to walk you through the process of figuring out the BMR for this normal rat here. And the instructions here are up at the top, and to go on to the next instruction, you're going to scroll down to the bottom where it says next right here. So I'm going to scoot this over a little bit just so you can see that a little more clearly. So when you're ready to go on to the next thing, you're going to click on next. And my advice is to just do what's on the page. So without further ado, because I have a time limit on this thing actually, I'm going to go ahead and drag this guy into the container. And so far, hasn't told me to do anything, so I'm going to click on next. Now it says select weigh to determine the rat's weight. So we're just going to weigh it, and we have a weight of 250 grams. You don't have to record that anywhere yet because it's going to save all this data. Then we click on next again. We're going to select the clamp on the left tube, the top of the chamber, to close it. See here where it says clamp open, we're going to click on that, and it's going to say clamp closed. So now the only oxygen the rat is breathing is the oxygen inside that closed system. This is how we would carry out an experiment like this normally. So then we'll click next again, and we're going to set the timer to 1 minute. That is 100, because you'll notice when I click the plus button, it only gives me 5 seconds. So we're going to click that all the way up to 1 minute. Hopefully you can't hear my clicking too much. Then we are going to select start. Now this is where we're actually going to carry out the experiment and test how much oxygen that rat consumes in 1 minute. What I want you to notice here is, as we do this, the levels in this manometer, which is a way to measure the difference in gases from one point to another, are going to change. So just watch in the middle here and watch what happens. Right now they're level, and that's what we want to get in the end. So you'll notice that up here on the left side it's rising because we're consuming some of the oxygen that's in this tube. So as the amount of gas becomes less, the amount of water rises to fill that space and decreases in volume on this side. So now we've done that, we're going to click on next, and now we're going to select the T connector knob, and this way we're going to connect the manometer, this part here, and the syringe. And we'll see where the syringe comes in just a minute. So now they're connected, and now we're going to click next again. And we're going to open this clamp here because eventually the rat would run out of air and we don't want the rat to die. So we're going to open that clamp. Now the rat is able to breathe all that sweet, sweet outside air, and we can start collecting some data. Now there's a lot here. So what we're going to do, we want to observe the difference between the level in the left and right arms of the manometer. So we're going to estimate the volume of oxygen that we're going to need to inject to make those levels equal. And the difference between these two is the amount of oxygen that was consumed by this rat. So I'm gonna estimate that this one is at about 13.5 or so, and that this side is at about 7. So what we want to do is take the difference between those and inject that amount of oxygen. So I'm going to start, and this may not be the final value. I'm going to start by injecting 6.5 milliliters of oxygen. That's 13.5 minus 7. And unfortunately, I got to click on it every single time, and we're there. So now I'm going to go ahead and inject. And what we're looking for is for these two lines to be level and for the word level to show up. If it doesn't, then we need to add more. If the word level shows up and then disappears, that means we added too much and we got to back off a little bit. So I'm going to inject this and see what happens. And you notice that there's a close-up here that shows that we're getting closer and closer and closer. And eventually we're going to stop, and it looks like we're a little bit short. So I'm going to go ahead and inject just a little more. Let's try another 0.5 milliliter. Ooh, we're very close. So I'm going to add 0.2 here, and that's going to get us there. So it looks like now we're level. And so now that we're level, we're going to keep that right where it is. We're going to click on next again. And we're going to enter that oxygen consumption. So what we want to do is we want to calculate the oxygen consumption per hour. And luckily, knowing what we know about time, that's actually a pretty easy calculation. But what we're going to do is, since we have the amount of oxygen consumed in 1 minute, because we set the timer for 1 minute in the beginning, we're just going to multiply that by 60. So I have my calculator up here somewhere. We're going to take that 7.2 and multiply by 60. And we're going to get an answer of 432 milliliters of oxygen per hour. And that's the number that we're going to put here. When we submit data, it's going to save that data. So we don't have to worry about it again. So now, we just calculated how much oxygen this rat would consume in an hour. And what we want to do now is convert that to a metabolic rate per kilogram of body weight. That's actually how the basal metabolic rate is calculated. So what we're going to do is we're going to take the milliliters of oxygen per hour, and that is 432, and we're going to divide by the weight of the rat in kilograms. So if we scroll down, the rat is 250 grams. And if you've done some basic math over the years, that you know that 250 grams is going to be 0.25 kilograms because there's 1,000 grams in a kilogram. So we're going to take 432 and divide by 0.25. And so this is our basal metabolic rate, 1,728 milliliters of oxygen per kilogram per hour. And so we're going to submit that data. And the last thing we're going to do is to palpate the thyroid. This is actually something that they do for my thyroid when I go in for my yearly exam. They want to manually check the size of the thyroid just by touching it, just by feeling around the neck where the thyroid would be located to make sure that there's no enlargement or that there's no goiter present. we'll get back to what a goiter means in a little bit. So we're going to palpate the thyroid, and it looks like the thyroid's looking pretty normal, no remarkable findings, and that's to be expected since we have a normal rat here, meaning its thyroid is there and its pituitary works just fine. So now we are going to record all that data, and it's going to record everything that we just did. Now, after we do that, we're going to drag that rat from the chamber back to its cage. We'll take the normal rat, put it back here. We're going to click restore. So everything's going to go back to its normal state. Then we'll have a question. So the remaining rats, so one rat is thyroidectomized, which means that its thyroid will be removed. We've talked about the role of thyroid hormones in metabolism, so you can probably predict what's going to happen. The other rat will have its pituitary removed, and we remember that pituitary hormones, such as TSH, for example, stimulate other glands. So there might be issues with the thyroid as a result of the pituitary not sending its hormones. So I'm gonna go ahead and eliminate this answer for you, and I'm gonna let you predict this when you get into the lab yourself. But basically, you're gonna go through the rest of this, testing the thyroid-ectomized rat, number 2, and the one who has its pituitary removed, number 3, in that way. I'm going to wrap this up because we're already running long. We're at about 12 minutes, so hopefully that helps you kind of figure out what we're getting into, and we'll take it from there. So hopefully I'll see you later, and otherwise, good luck with everything, and let me know if there's anything I can do to help. Thanks.